Hello everyone, I want to teach you Matlab. This is our third session and I'm ready to teach you how to use Matlab. First of all, I define two matrices. For instance, A, it's equivalent to whatever. And B. I want to define the size of these two matrices. For this, I use size command, size A. As you can see, we have a matrix 3 by 3. So what if I want to determine the size of matrix B? As you can see, this is a result. A matrix with 1 row and 7 columns. 1 row and 1, 2, 3, 4, 5, 6, and 7 columns. I want to have a matrix that's all of the elements are 1. In order to demonstrate a matrix that's all the elements are 1 or 0, I should use this. What if I want to a matrix that all the elements are equivalent to 1? For this, I type this. For example, y is equivalent to 1's size A. And I want to put the size of my matrix to the size of matrix A. As you can see, this is the result. In contrast, I want to have a matrix that all the elements is equivalent to 0. For this, I type Z and I put it equivalent to this command 0s, for example, size A. And this is our Z matrix. In this step, I want to explain how to multiply the matrices with each other. First of all, I should add on, for this purpose, we should have some similarity in the size of matrices. In this way, I should first of all determine that what if the number of the columns of the first matrix is equivalent to the number of the rows of the next matrix. If the answer is yes, then congratulations, you can multiply these matrices with each other. Otherwise, you are not able because you don't have permission based on mathematics rules. So let's get started. I want to define matrix C like this. 1, 2, 3, 8, 14, 19, so whatever. And I want to define matrix D like this. -2, 4, 3, for example, 18. As you can see, matrix C is a 3 by 2 matrix. On the other hand, matrix D is a 2 by 2 matrix. The number of the columns of the first matrix, which is 2, is equivalent to number of the rows, matrix D, which comes next. And I want to multiply these matrices with each other like this. C, D. As you can see, this is a result. Now I want to define the role of dot in matrices. The point is, if I want to make any changes and multiply or divide, and using mathematical operators in matrices, I use dot. I want to make a shortcut and I don't want to write and that particular value, and I want to apply that particular operator just once in a matrix. For this, for example, I have a matrix E and I want to divide all the elements into, for example, 10. As you can see, I put dot priority to division sign, and this is how dot sign works. Here I want to make another example. For example, I have a matrix X, which is a 1 by 8 matrix. I define X something like that. 1, 8. Like this. On the other hand, for example, I have this expression. For example, 2 in power 2x. This is the result. As you can see, we have an error here, and this is a mathematical operation, and x should be a scalar. If I want to modify the previous error, I should do that. 2, and before the mathematical operation, I put dot and then x. As you can see, the number 2 has reached to the power of matrix X, and 2 in power to 1 is equivalent to 2. 2 in power of 3 is equivalent to 8. 2 in power of 5 is equivalent to 32, and so on. In this step, I want to have an inverse matrix. For this, I type, for example, P. I select matrix E, and I come here and I type E, and this is the result. Here I encounter a problem, and the problem is that my matrix should be square, and as you can see here, E is not square at all. For this, I select matrix D, which is a square, a 2 by 2 matrix. So I come here again, I type inv and then D, and this is the result. As you can see, this is my inverse matrix. There is an alternative method. For this, I type, for example, double P, and I type D, and matrix D should reach the power minus 1, like this. Excuse me. Again, I type. As you can see, this matrix is equivalent to this, and there's no differences between them. All the elements are equivalent. For the next step, I want to specify the determinant of a matrix. For this, I type det, and I use this command. I want to specify the determinant of, for example, D. As you can see, this is the determinant of my matrix. I mean matrix D.